Hello, Richmond.
I need a plug-in for my headphones.
You don't have a plug-in?
My Bluetooth hookup. My Bluetooth headphones. So I have to listen to by street like this.
Is your Bluetooth headphones spoiled, or is it the problem with the laptop? If it's the laptop, I can take a look.
You really want? You want to solve my problem for me? Oh, all right. So here are my little sad headphones.
Okay.
Okay. Somebody from Richmond, let me know if that's better or worse. Harper mentioned that depending on how I turn my head, sometimes it gets really loud.
Yeah. That was when you didn't have it clear.
Okay. So hopefully that's better. So, what did y'all think of that? Did that kind of solidify some of the concepts or make you more confused?
I mean, it makes you realize how hard it is to break down and conceptualize how things are related.
It forces you to see what you know and what you don't know, and hopefully inspire you to go get better at the things you don't know or it's not very clear. Which group came upon something that they debated, and you could see it more than one way? And this includes Richmond, because if you want, we can switch over the feed after this short session, and we can have one of you all explain your database diagram and see how you all ended up.
We had disagreements in ours, primarily over the use of junction tables and many-to-many relationships. The basic idea of ours was for a food blogger who sells meals to people by the week. These meals.
You want to actually. Why don't you come up here and say it so that Richmond hears it? Because I'm not going to be able to repeat. You can have a seat here and. Just sit here so that they can hear you.
Sure.
And Richmond, let us know if you can't hear him. This is Scott, by the way.
Hi, guys. Yeah, so our group debated on how to use many-to-many relationships. So we have a customer, and we have recipes. And each recipe has a certain type of dietary restriction. And we used a many-to-many relationship there. Recipes can have many customers, and a customer can have many recipes. Our junction table, we had customer restrictions.
Customer restrictions.
Yep. And so this was whether or not they had dietary restrictions. And that's how we connected it.
How is recipe related to customer?
Many to many. So a customer can order it by recipes.
Okay. So is there another table here somewhere? Or is it this one?
It's that one. We used that as our...
No, we have customer related to restrictions. Related to restriction type, right?
Yeah. So there's one coming off of this, but this is just restrictions that goes to recipe.
So one problem is if you have a given recipe, it could have gluten in it. It could have sugar in it. You probably have a more complicated relationship for a given recipe, right?
Yep, and that's why we try to go down by restriction type.
Okay, so you got a restriction type somewhere over here?
And it connects to this.
Okay. Type. To help everybody understand, what's an example of a record in restriction type?
Carnivore or vegan.
Vegan, okay.
Or gluten-free.
Good. That helps everybody understand what you're talking about here. So one customer could have multiple restrictions.
Yes.
Okay.
And then from there, we said that this is where we kind of got into some issues because we wanted to connect ingredients with restriction type and then back to recipe. And so,
The reason for that is an ingredient may have a restriction associated, like it has gluten in it?
yes.
Okay.
And so we break it down even further. So we had an ingredients table and then multiple many-to-many relationships connecting restriction types. So we have carnivore restriction or carnivore ingredients, vegan ingredients, and gluten-free ingredients.
Like that?
Yeah, basically.
We had multiple of these.
What are the other ones?
For the different restriction types. But I guess it can all just go in.
You got a relationship. You just got one.
Yeah. And then we bring it back around and connect recipe to ingredients.
What's the relationship type?
Many to many. A recipe can have many ingredients, and many ingredients can go into a recipe.
Alex, why is there many to restriction type? And
Because there could be multiple restriction types. You could be vegan and gluten free. Right. And you want to get.
Yeah, in case somebody has multiple restrictions.
So this is about where we ended it. We did have recipe connected to customer restrictions, and then we had a meals.
What is that? Explain that relationship. Recipe to customer restrictions. So a recipe is like, I don't know,
A component,
chicken primavera or something. It's
Right.
like the end dish.
not the end dish,
No?
because a meal can have different recipes. It can have different components, right? So,
Exactly.
right? Our example was like lasagna has its own recipe,
But
and
you
then
garlic
salad.
knots with your lasagna. Yeah.
Right, right. So I guess we shouldn't have even done that and just done like meal to customer, because a customer can order many meals, and a meal can go to many customers.
So you're talking about ordering these things too?
The end result would be
Yeah,
a
order them.
week-long meal plan.
So that would be a separate set of tables.
Yeah, and we left it at this.
Good. So y'all are saying, okay, that's where we would go next if we had another half hour.
Right.
But how do you connect it? Do you need anything to connect that to the customer?
Well, that's why this is where the technology meets real life. The question is, do we need to connect customer to recipe or meal? And the answer is yes. How do you do that? It depends on what you're trying to do. So I could draw a line, but it's going to be completely inappropriate without me asking more questions about what are you really, in the real world, how is a customer related to a recipe?
So we're not.
They're in it.
Your order.
Kidding, I was saying eating.
Yeah, it's like, wait a minute.
It's just.
Yeah, I mean, I'm sorry, I can't hear you.
Are these repeat known customers, or are they just walk-up customers? What kind of?
So Brian, once again, focused on marketing. He's like, where are these customers coming from? And are they repeat customers? Are they one-time walk off the street? Another question, Michael.
So we didn't need this, we needed
No, I'm
this.
talking about this connection,
Like
restriction to
restriction
recipe,
and recipe needs to be connected. We don't need to necessarily have vegan.
right? So customers.
Yeah, he said, what if a customer has their favorite recipe and they want to submit it or suggest a recipe? That would probably be a whole other set of tables, because as soon as they submit a recipe, you don't want it going in the real recipe pool. You want it kind of be reviewed, because maybe they're going to start eating people or something. So you want to have like a customer proposed recipe table, and then you had to have application code. And this is where the rubber hits the road. You have data, but the data doesn't move around or do anything without an application, without writing code. So the database administrators and database developers have the luxury of not thinking about how things move or how data gets into their tables. They just design the buckets. And it's the application developers, when you're putting on your DBA hat, oh, that's somebody else's problem. It's not my job. So as a database administrator, yeah, you'd create 5 more tables, 5 or 6 more tables. Like, okay, customer submission. What's in the customer submission? Can they submit more than one recipe at one time? Maybe. And then each recipe, you have to get all of the ingredients for that proposed recipe and so on. So very good. Don't put the chair back because somebody else is going to come up right after you. Who else wants to share?
Oh, we got a very good.
That's good, yeah.
We got a very good.
Yeah, I see. The only question is you'd probably have more discussion about your business model and how you'd connect these two. You'd probably have another table. You probably wouldn't be direct, but it really depends on what you're trying to do.
We have a final question. So, should recipe connect to restriction type?
No, the customer restriction.
No. Here's a rule of thumb. If you have a relationship through another trail, it's usually not necessary and usually a bad idea to have a second connection. Because how do we connect these? What's the code that we use? What's the syntax we use to actually put these back together?
Using the foreign
join.
key, a join, yeah.
Yeah, foreign key, primary key, join. So this would be a 1, 2, 3, 4, 5 table join. That's all. So you get it out. So it is connected. It just connected through these other tables.
Okay. Yeah.
But how would that look? So would you have to do like restriction type, inner join to this, inner join to this, inner join to this, inner join to this?
As a matter of fact, we're going to see that, yeah. Because he taught you like 2 table join.
He said not to do that. He said best practices, or you shouldn't do more than one join.
He has his DBA hat on. He doesn't care about the real world. Okay? In the real world, it is very common to do 5 or 10 table joins because that's the way your database is modeled. How do you get it out? Well, you have to put the information back together through joins.
So you're saying if we changed one little thing, we'd have to change everything again?
That's a leading question, and I'm going to say no.
So
I don't know what you're saying.
Let's say we have one more restriction type now. Let's just say the customer goes, oh no, I'm also vegan with being non-vegetarian.
Okay, let's do that scenario. Let's test the database like that. And this is excellent. This is the kind of debates I wanted you all to have. So what happens if Dave comes in, it's like, oh, I forgot I'm vegan. Or, tomorrow, I'm going to be vegan starting tomorrow. I saw this horrible video online. It's like, I changed my mind. So he wants to add that restriction. How do you do that in your database? Kirsty, defend your database.
You just add a column, right?
Do we add a column?
No, we just update the customer field. Set it to 1 hour.
Okay. Take it slow. So Dave comes in and it's like, I was on your website yesterday and I've turned over a new leaf. I'm going to be vegan tomorrow. How do you tell your database? How does he come in? What does he do?
Well, doesn't he just change that he's vegan up in his customer spot and then it outputs whatever?
We haven't talked about the column, so maybe you do have this wrong. So customer, all you have here is first name and last name probably, an account number, and when they created their account. The restrictions live here, right?
How do they put that in though?
No, the customer also has
How do they tell you
their
they have it?
restriction.
So Dave came in yesterday and he said, I've got a nut allergy. So what that would look like is there is a record over here called nut allergy. And Dave is like customer number 1. So customer restrictions would be customer ID of 1 has restriction type of 2. So if he came in tomorrow and said, I'm a vegan too, he would add 1 more record here. Now, this is where it's a little bit confusing because we've skipped the entire middle tier. As a database administrator, you don't care about how that happens. It's the application's problem to store the data the right way. So the application would get the restriction type of vegan. The application would get the record for Dave, and it would know the foreign keys, the primary key for each, and it would store a record here for you. So to answer Mudit's question, we would add a record. So that's how you know that this database design is solid.
Yeah, no,
If you have to change the structure to accommodate normal data, you've done it wrong.
I didn't mean that. I meant in terms of when you're updating it. So that would update each table, right? Because that would have to go and tell ingredient restriction. Okay, so now only include the vegan, right? So the query would update
I'm not understanding what your requirement
the
is.
selection.
So you're saying,
from, let's say, from a meat eater, he goes to vegan. So instead of having recipes of meat, they'll have to change the recipes of vegan, right?
okay, so you're thinking about, Mudit is jumping ahead and he's thinking about, I'm thinking about this application screen because I really want to use their application that doesn't exist yet. And I may actually want to apply my vegan or vegetarian restriction. How do I do that so I see appropriate recipes? All of that is about queries. All of that is dynamically building a select statement doing, they've selected vegan or vegetarian from the restriction type drop-down list in the user interface. And based on that, the application is going to build, it's going to know that that's restriction type of 4 for vegetarian, and it's going to do a query to try to find whatever other information you want. But you don't change the structure. That's how you know that you've done your database right. If you have to change your structure to answer normal problems, you've done something wrong. Because the developer is not going to sit there and wait for Mudit to come along and then write code and change this database structure for Mudit. You have to make it so that adding records will accomplish the goal.
That's what I meant. Yeah. Just, you'd have to use queries, and it would have to just go through the whole thing.
So you were pretending to be a student, is what you're saying. Okay. Thank you for leading me down the path. So how do you add a record here? You'd have an insert statement. Okay? Where does that insert statement get executed? From the application tier, from the server-side application tier. Why does it get executed, and how does it know what to enter? From your user interface. Your user interface has a drop-down list, and it's got a little key. As a matter of fact, if you open up, and y'all have, I'm sure, done this since I showed you how to do it the other day, go on the web and you open up a website, view source. If you look at the selects, there's a little value attribute, and it's usually some crazy number. It's probably the primary key of the data in that table. And all they're doing with that select is showing you the primary key and the description of whatever they want for that row. You see how it's coming together? Slowly but surely, we're showing you the front, the back, and we're going to go back and show you all the middle about how the front end communicates with the back end. And that's going to be C#. So for now, you have the luxury of forgetting all about the rest of the code. JavaScript doesn't exist. You don't know how to read it. I don't know what HTML is, Just data. All you care about are the relationships. Get this right, and it's somebody else's problem, your problem, in 2 weeks to figure it out. So, anybody else want to share? Anybody from Richmond? Anybody else from Winston-Salem share their ideas?
So when you have the primary keys and the foreign keys to the child relationships, do you have to keep adding additional foreign keys to reference back to the parents?
So the question is, she gets the primary key and the foreign keys are always added to the child table. Do you have to continue to add foreign keys to reference other parents? And the answer is yes. So if you're, let's say, recipe ingredients. Recipe ingredients is a child table to both recipe and ingredients. But let's say you also care about where you sourced that ingredient for that recipe. Say it's weekly and you're putting together kit meals. You probably have a vendor table or something like that, and it would be a one-to-many. And in order to make that happen, you would add a column and a foreign key to this child table to also have this as a parent. So the answer is yes. You would just add another foreign key.
So it's only if it's to the parent key. So like for instance, technically that, let's say recipe ingredients, has a relationship kind of to meal.
It does, through joins.
There's not going to be a foreign key for meal inside the recipe.
Oh, I see what you're saying. She's saying, well, recipe ingredients has a logical relationship to meal. Shouldn't we have a foreign key here? The answer is absolutely not. Whenever you have it connected one time, the right way to get from recipe ingredients to meal, if you want to say, show me all of the ingredients and all of the recipes for this meal, that's the answer that you're providing to that question. You would do a join. Table, join table, join table. What type of join is it? It's an inner, because you have to have a match in this case. It's not like, well, I may not have any recipe ingredients. No, it's like, I want the recipe ingredients for the recipes in this meal. So it's an inner join across 3 tables. That's all it is. It doesn't change the structure. You're just writing a SQL select statement. Another question? Oh, Stevenson wants to share. So come on up here so that people can hear you. By the way, Richmond, can you hear when they're up here? Did you hear Scott when he was explaining the database? An indication, yay, nay, 1, 0, true, false. Go ahead and have a seat.
I'll face hard.
Yes.
Yeah. Yes, thank you.
Okay, we revisited Anna's situation with the mattress and the engineer. and we asked more questions. So we got down to what he actually does, and it's not the finished product of the mattress. So the first thing we had was the customer.
So he does deal with customers? Okay.
He does deal with customers. And the customer is ordering a product.
So he orders like mattresses?
Yes.
Okay.
But there's also an order.
So there's an order table? How are those related?
We have one customer to many orders.
Okay.
And then we have an order line underneath that. So we have one order to many order lines. Okay, and then we have the components.
Well, we've got a product out there too.
Yeah, we have product. I'm getting at that too. I'm telling them all of it.
Okay.
So in that we have a product, and the product was connected to the customer and the order. So the way we did that, we have a product box.
And product is like styles of mattresses?
Correct.
Okay.
So we have one customer connected to many products. Just in case they, on their order, they wanted to order multiple designs.
Walk me through in the real world what that represents and how we're going to draw that.
So on this, we had the primary being the customer.
Okay.
Connected to the actual order.
So Stevenson White, order 1, 2, 3.
Correct.
And he is ordering 2 mattresses, so you'd have 2 rows here.
Right. But we also, when we did it, we connected our customer to the product because they wanted to look at the products.
When you say look at the products, is that within an order context, or they have
Yes,
like a favorite
within an order.
product? Or is
Within
it like a
order.
lead? They came into the store and it's like, I really like the King Sleeper over there.
Yes.
Okay, so that would be a different table over here. That would be like customer leads or customer interest or customer favorites.
Okay.
We did it by internet, actually, like they were
Yeah.
ordering on the internet, and what they saw was a list of products, and they would pick the products that they want.
Like in a shopping cart?
Right.
Well, that's what order lines are. Each item in a shopping cart is usually, that's the digital form of an order line.
Okay, but they have to know what product to pick.
Yeah, they've picked it on the screen. But an order line needs to know which product they're buying and the current price.
The database has to have what those products are.
Yeah, there's a product list. So the product list by itself, that simple table is like, here are all the products, here are all the mattresses we have on sale today. And how do you tell? You probably have like an activity date. You have a date that's like expiry date or something. And if the expiry date has a value, then it's obsolete. And if it has a null, then it's active, something like that. But yeah, it's just usually one table for product. But order lines have when you're ordering something, that order line knows I'm ordering that product, so that mattress. So you probably want to do something like this. So you have, this is the 1-to-1 again.
Okay, but how do we know what customer goes to that? We have to get.
You know the customer ordered that, and this belongs to the order, and this belongs to the order line. So it's a join. Yep. Yep, so you'd have a foreign key here. So this would be product ID. This would be ID. This would be ID, order ID. And this would be customer ID. This would be ID. So it would be inappropriate to connect it directly. Because if you think about Stevenson White, and he's connected directly to the King Sleeper, Stevenson could change his mind tomorrow or next 5 minutes. You don't want to tie him into one product ever. You might have something like favorite product ever. Okay, then it makes sense. It's like, okay, there's only one of your favorite product ever, but probably you have more than one favorites if you frequent the store. So you probably have another table. That would be a many-to-many again. So that's a common mistake when you first learn about this stuff. When you have it connected one time, usually that's enough because that means you can do a join. That means customer, inner join order line, inner join product. You've got your data. Remember how the users, once again, who are your users as a database administrator? the application developer, yourself, really, 2 weeks from now. Your 2 week in the future self is going to be your customer. That 2 week in the future self probably doesn't care about the keys in the database. It's like, I don't care, it's 35, you know? I want to know, tell me the word that is the product that Stevenson ordered on that day. So you can join all that stuff, and you just don't return it in your select. So to him, you got all the information. For him, it looks like one big table, but you've structured the data properly.
Okay.
So what else you got here?
So we also have the components.
Okay, is that off by itself or is that connected?
It's off by itself.
Okay.
And we connected the components to the order.
So the components, but you didn't sell a spring, you sold a mattress. How did you connect it to the order?
Sell anything. That's part of what we did was an actual flow chart of what he does.
Right.
And so he doesn't actually interact with the customer directly. He gets an order that says this is what's needed, and then he pulls all the components and puts them in a build of materials, and then that's where his responsibility actually ends. He sends it off to inventory to pick them and put them into manufacturing.
So he's building a pick list.
Exactly.
Okay, so building a pick list, he's got a list of components that need to go into this order, and the order is like the driver of what he's got to prepare.
Yes.
It's like his to-do list.
So it actually ends at the bill of materials.
Okay.
For his case.
So in that case, none of that is relevant. This is why you got to think about asking the right questions. It's like, if he doesn't deal with orders and order lines, don't put it in your database.
But he does deal with orders when they get
Not directly. He uses an order as his demand driver. So his, like, you could call it whatever you want. It's like my action items, or you can call it order, but it's not really order, because if somebody from the marketing database comes in and sees, oh, you call that order? That's an order line. You're mixing paradigms. So really what you're talking about is product line request. Line request. And there is a product. You had that. You could have a request for the same mattress over and over. So you got one definition of the mattress, but you got to build 10 of them today. Each line request has a list of components. Okay? Now, how does he know when he's done? So this is like what I've got to do, and what he's going to actually do is maybe a kit. And a kit is going to be really one-to-one. Let's make it kit contents. So this is like he's putting all the components necessary to build that line.
Right.
So you've got that, and you're going to have like a completed at is probably a nullable date time or date time stamps, like, oh, I finished that one, it's done. And that's how you know it's go on to the next one.
sends it off,
Yeah.
Right.
whoever the next guy is.
You probably need to know like a routing, like who's going to build this kit, who's going to assemble it, which product line. I don't know, if he cares about that. That's probably somebody else's job.
Yeah, I think
Right.
from what we understood was that once he puts what you're calling kit together, in other words, all the components that create this order,
Usually it's a box that have a bunch of components that haven't been assembled yet.
he just
Yes.
sends that off in an Excel spreadsheet currently to somebody else that goes through inventory, physically picks it, takes that to manufacturing, and manufacturing builds it. So once he does the kit, he's done, and sends it off, he's done.
Yep.
Right. And that's what we left off at, like the bill of material on that part.
So the bill of material, so this is a definition of the components, like spring ABC. You probably have a bill of material that says, if you're building that finished product, this product has a bill of material. And it's going to be the hierarchical relationship of how to build that product. And each one of these relates to a component. So you would have that relationship as well.
I was gonna say, when you have a relationship, that
So what did we learn here? We learned you need to focus on what exactly the business problem is. Just because you build the right relationships, if you built relationships that are completely irrelevant for what they're trying to build, you've wasted your time. Put your blinders on. What is it we're trying to solve? Question.
which I both agree with and understand what you're saying. However, this would be in a real world situation. Yes, this fits his, but you build his only just his little piece of the database, or it all. You get the management of the company involved to do the entire process, because what we do if we just do this one little piece.
Good question. So let me repeat what Brian was saying. It's like, yeah, I get what you're saying, Ali. You want to focus on exactly what Anna's husband's doing, but we're leaving about so much value. I mean, all we have to do is create 3 or 4 more tables over here. We should probably go talk with the executives of the company and tell them we could build this, this, and this. And the answer to the question is, who's paying the bill? If Anna's husband is contracting you to go build his database, he doesn't want to pay for your time to go build off tables that he doesn't care about for other departments. If the executives are paying your bill, yeah, it's like Anna's husband may or may not get everything he wants. Unfortunately, that's the way the real world works. Of course, if it's only a table or 2, you slip it in. But yeah, so that's the real world creeping in. Everybody understand the basics of primary key, foreign key, parent-child, one-to-many, many-to-many. Anybody else want to talk us through what they did? Thank you, Stevenson.
Oh, thank you.
Anybody in Richmond particularly proud of what you all came up with? Okay. Hopefully that doesn't mean that you don't get it. It just means that we're ready to go on to something else. Challenge us. Okay. Let's do some challenge stuff. You learned the basics of SQL. Let me teach you some of the things that Derek was probably afraid to teach you. On more than one occasion, he told you, I'm just touching the tip of the iceberg. I'm that type of guy. I'm going to show you the whole iceberg, and if you want to ignore half the iceberg, do it at your own peril. So, primary key. You're going to hear about these things possibly in an interview, and I need to tell you some of the technical terms just so you understand what they're talking about. The ID fields, the auto numbers, the identities, those things that kind of automatically take care of themselves, the technical term for that is a surrogate key. A surrogate meaning, like, whenever I think of the word surrogate, it's like, okay, somebody didn't want to have a baby themselves, they couldn't, so they found a surrogate mother to go and do that.
Smaller camera.
What's that?
Smaller camera.
Smaller camera, sorry. Yeah, I don't blame you. The horror. There we go. Better. Okay, so I'm not showing anything yet, but I'm about to. So, surrogate key. Surrogate because you've kind of copped out. You've kind of said, I don't have the creativity, or I don't have the ability to identify some real data in this world for this table that's going to uniquely identify each row. So the definition of a primary key is, it's one job in life. Uniquely identify a single row in the table. That's what a primary key does. That's why it's called primary key. Now, if you have some data that naturally identifies a single row every time, you should use it. That's what's called a natural key. Can somebody think of a good natural key in a different context?
Social security numbers.
Okay, this is where developers really begin to hate their job sometimes. It's like you would think, and these are the developers back in 30 years ago said, Social Security number ought to be unique. It's going to be, I put Scott in, and Scott's going to have Social Security number 111229933. Okay. That should always identify Scott. And we're going to have Social Security number anyway, right? So let's just put it in there. We'll save the overhead of having this surrogate key and have this auto-generated integer, and I didn't want to deal with that anyway because it doesn't make any sense. How much nicer would it be to say, select where Social Security number is equal to that, and I get one record back? And that worked well for about a year. And then the federal government came back and said, you know, we're probably going to eventually run out of Social Security numbers. So after somebody dies and they're dead for like 50, 60, 70 years, we're going to reuse them. All of a sudden, you've created a huge database problem. They didn't care, but they made your life hell. Because you got to go back, it's like, oh my goodness. Now I've got two people, and you know what happens when somebody tries to enter the same Social Security number as something you already have?
It explodes.
It says you can't create a duplicate primary key. Sorry, go away. So your application fails. So they can't, that second person, no, nothing doing. What happens if somebody steals somebody else's Social Security number? The moral of the story is, I can tell you from painful experience, it may look like you have a good natural key, and I'm teaching you the technical terms for these, natural key, and there are good natural keys. For instance, if you're creating a database for the zoo, and you want to say, you know, I've got a serial number for each of these animals, and a serial number is something that's assigned somewhere else in some other database, and I've also got the kingdom, phyla, species, all that stuff. You can probably mix those up, and multiple columns would uniquely identify exactly one animal. Location, you can put things together and make a pretty decent primary key without having to do a surrogate. Let me show you what that looks like in SQL. And this is why you're going to very quickly come to the conclusion that I probably don't want to do natural keys or anything other than surrogate. So let's pretend that we have a database called animals, animals table in a database. And I've got animals and I've got the feeding times of those animals, okay? So the database is like zoo. You know, I'm going to show you how quickly and easy it is to create it. We're going to create one called zoo. And I'm going to create two tables. Animal. And I'm not going to have a surrogate key for now. I'm just going to say it's going to be identified by serial number. And that could be, they're going to throw some dashes in there, so it's not really going to be a number. So we got to make it a varchar, variable character. And we're going to have species name. And really, you'd have a separate table for species, and you'd have a foreign key, but we're not going to get into that. So species name, varchar 100. And you know what else is maybe the name of the animal? And their current location. Now, these are really, in a real-world database, you'd have foreign keys. And these would all be their own separate tables. And to Anna's point, you'd have another foreign key to that table and that table. But we're going to make it really simple just because that's not my point here. So you've got an animal and you've got feeding times. Notice I didn't have a surrogate key. I don't have an ID column there. I don't have an int at all. That's fine. You don't have to. I'm going to show you how painful it is to do without it, though. So the feeding time, you actually have to feed an animal. So the way you write, here's another term for you. A composite, depending on which country you're from, if it speaks English. You specify, here are the columns that uniquely identify one row. So I've got 4 there. It's called a composite key or composite key because the primary key definition is made up of more than one column. It's composed of more than one column. So I'm teaching the technical terms that you may be able to use in an interview someday. Surrogate key is that ID that's auto number identity. Composite key is more than one column, makes up the definition of the primary key. Natural key means you have data that the real world knows about. It's not some auto-generated number, like Social Security number is classic case of a bad natural key because it worked for about a year until they changed their minds. That's an example of a natural key. Now, here's why composite keys and natural keys often are a bad idea from a developer perspective. Developers are what? Lazy. So if you actually have a composite natural key, oh my goodness, you've got to copy and paste all 4 of those columns. because the foreign key must actually have the value of the primary key. So you've actually got to copy and paste all that stuff. Worse than that, is this going to be good or bad for performance? Bad. Look how many characters the computer's going to have to match. You could have 200, 300, 420 characters. It's got to match. Just do a simple join. Okay, and then we haven't even added the data for the feeding time. It's like, okay, at what time of day? Is it morning, evening, or night? So it's like time of day. So now you have all the other columns related to feeding time. Not only that, you end up with columns, like 20 columns in a table, and 3 of them are interesting. So it's a lot more to look at, and a lot more to deal with. You know, it's my personal preference, obviously, but here's another way to do this. Let's make it, okay. So I've got a primary key, foreign key, and then I've got all the other stuff that I actually care about for feeding time, like who did it, trainer ID, ints, not null, foreign key, references, users. So that would be like whoever fed the lion. You need to know who did it on that day. So, moral of the story is this is how you create a composite key. Sorry, ever since I spent time in the UK, I don't know how to say that word because they say it differently over there. So here is a primary key. It's also known as a what? That ID column. What's the technical term for it? Surrogate key. Surrogate because you're generating it. It's like, let the database table take care of it for me. Is that good or bad for performance? It's good because down here, let me show you why it's good. Okay, so we have, here are the data types, and this is, I'm not going to spend a lot of time in here, but the data types and their internal storage is online. It tells you what is the maximum size of number I can store in an int column. There it is, 2 to the 31st, or negative 2 to the 31st. Small int, 32,768 negative, 32,767 positive. That's the range. If you try to put a number bigger than that into a column of small int, you'll get an error. This is what you care about for performance. 2 bytes on disk. The smaller the number of bytes that you have to look at as in terms of the database optimizer, the faster the pure performance you're going to get. And the more your users are going to love you compared to all the other developers that don't even know about performance or don't care. It'll work. This is the difference between good and bad developers. You can write a database that will work. It will be logically consistent. It may be dog slow. And because it works, nobody's ever going to go back and change it. Please don't do that. Please understand. Do I want to have a varchar as my primary key and foreign keys? No, because I'm showing you 4 bytes for an int, and that will handle most cases. So you're saying 4 bytes for each row here, match to 4 bytes over here for your primary key column. Match it for joins. And you did that all day long in relational databases. Even if you have a big int, and you're never going to run out of those, 8 bytes. If you have a first and last name, commonly you have 25 characters for a first name, 25 characters for the last name. So all of a sudden you have 50 characters. You're more than 5 times slower if you chose to make that your primary key and foreign keys. And you're going to know it. Your users are going to complain, and you're not going to know how to fix it. This is why. The biggest driver of database performance is getting the data off of disk and doing the joins. Tiny, slim, sexy. Okay? And I'm not talking supermodels. I'm talking data. So skinny is fast. So natural key. You have data in the real world that the users identify as this will uniquely identify every row in this table. Very rarely is that the case. And I've found, even if you trust the users, they say, oh, it's never going to change. If they can see it, they're eventually going to want to change it. That's human nature. So are they ever going to ask to change your surrogate key? No, because they don't even know it exists. Take care of yourself. Don't show them your keys. Composite key. That just made up more than one column. Foreign key. Y'all know what that is. Somebody explain to me what a foreign key is. Is it unique in that table? You define a foreign key. Is it unique in the table it's defined in? No. Probably not. It means it's unique in another table. Right. The other table's primary key. So that's how you do the joins. Primary key to foreign key. Referential integrity. Let me show you what that is. That just means I can trust your primary key to foreign key relationships. So let's get rid of all this stuff and let's create a very simple fed by trainer. Okay, so you don't have to have foreign keys defined. You can have, that will work, and you just kind of know. So I've just created two tables there. Oh, what did I do? I created it in the wrong database. Shame on me. Problem solved. How do I switch database context with code? Use. Watch it change. Okay, now I've created in the right database. Shame on me. So, animal, we've got ID and name, feeding time, foreign key. Now, there isn't a real foreign key here. Let's create some data. We're not going to specify the ID because it's a surrogate key. It's going to take care of itself. Somebody asked me, why would you ever do a cross join? Let's see why. Okay, and let's create an animal, a bunch of animals with crazy names. I have 10,201 rows coming back. This is a little hack that allows me to say, I want to take some database. By the way, what is that sysobjects? Does anybody know? SQL Server, as they say, eats its own dog food. They believe so much in their database technology that they store the data that defines the database columns and tables in their own database. They just have a system database table. And you can see it. It's not going to be inside of the database. It's going to be under master, tables. And there's a button. They try to hide it from me because they're like, you don't need to see that. They actually have hidden it now. Watch this, though. There's a list of all the databases on this instance. There's my zoo database that I just created. Here are all the internal stuff that has to go with my zoo database. So all this stuff, how does SQL Server do its magic? It puts its information into its own system database. That's how it's working. So, peeking behind the curtain there, don't mean to scare you. The reason I'm looking around, it's like, please don't go there, Allie. It's like, okay, we're not going to go there. We're not going to go there now. All I'm doing is I know there happens to be a sysobjects table. And that's going to give me a list of all of the things in my things meaning any type of object, including my tables, feeding time. Right there it is. It has a list of the objects that I've defined for this database. So what am I going to use that for? And here's the type it is. It's a user table. It's a service key, primary key. All these things exist as just elements. So why am I going to do this? So this is going to give me 101 rows. You know, I want more animals in my zoo than 101. A cross join will give me the Cartesian product. So 101 times 101 is going to give me that many rows. That's going to give me 10,201. That's enough animals for my zoo. People will come look at that. So instead of just name, well, name is like syscalls, and that's not very interesting. I'm not going to have any animals named that. So let's generate some names. So see how that looks. Okay, so strongly typed. I'm going fast. Sorry. Conversion failed when converting varchar value. So in JavaScript, what did I do? Let me show you exactly what the failure was there. I said zebra, which is a string. That's a single quoted in SQL. And I tried to add it to object ID. In JavaScript, that would have been just fine. JavaScript's like, oh, I know what you mean. I'm going to convert that number to a string for you. SQL doesn't help us out. You have to tell it, I want you to change your data type so I can concatenate you. There are two ways to say that. That's one way. Here's another way. They do exactly the same thing. So now I've got numbered zebras. People are probably not going to come see my zebra zoo, but it's better than nothing. So why did I do that? Because I wanted some animals in my zoo. So I'm going to put these together. I've now got 10,201 rows. There they are. Okay? Now, what was the whole point of this? I wanted to show you that referential integrity is a good thing to enforce. So notice up here I commented out this foreign key. So that means it's a logical foreign key, but I didn't enforce it. I'm not saying throw me an error if I do something bad. What might something bad be? I've got an ID of 10,201 is the maximum ID. If I'm going to say, you know, I'm going to feeding time, and animal 50,000. That's the key, and fed by my initials. And I haven't written that insert statement right. What's the right syntax? Help me out here. So these are the values, but
You need the parameters, column names.
yeah, I made that. That's a mess, isn't it? So help me out here.
It would be ID, except just plain ID, not animal ID.
Insert into feeding time. So this is that's the structure of the table. So it is an animal ID. Yeah.
Because you don't put it in ID, plain ID.
Yeah, ID takes care of itself because it's identity.
And then fed by trainer initials.
There we go. Now, what's the next keyword?
Values.
Good. And then it's like a parallel array. So think of this as an array, and this is an array too. By the way, database concepts, back to JavaScript. JavaScript, you've got square brackets for an array, and I showed you an array of objects, and each object had a property. What's the closest analog in database technology to an array of objects? Think out of the box here. It's almost identical. It's a perfect metaphor. An array of objects in JavaScript is like a what in SQL?
Like a view.
Like a table. think about it, a table is like an array. What are the elements of the array? Each element of the array is a row, and each row is composed of fields, which is like the properties in your object. Think out of the box. So in non-relational design come Wednesday, that's called a collection, but it's nothing more than a table. It's nothing more than an array of objects. Okay, I'll help. Some of you are like, what are you talking about, Ali? It's like, I'll talk with you at the break. So this is the right syntax for feeding time. Is this going to work if I write that statement right now? Uh-oh.
You didn't put any restraints on it.
I didn't tell it to be a foreign key constraint. So is it really there? Yep, it's there. Is there an animal or 50,000? No. That is what's called violation of a referential integrity. Referential integrity. Now, the reason I went through this whole example is to teach you an interview type phrase. Referential integrity means that if you have a primary key to a foreign key relationship, that foreign key is guaranteed to be in your primary key table. The opposite of what I've done here. I have violated my foreign key constraint intent. Now, I was able to do that because I didn't define a foreign key. Databases are just like other things in computers. They do whatever you tell them to do. So what I've done here is, as a matter of fact, if I try to do this, I can do an alter table and add the foreign key, but I'm not going to because it's a long SQL statement. If I go back and try to add that foreign key now, is it going to let me?
No, because you have a value now outside of the parameter.
It's not going to let me. And as a matter of fact, I saw somebody back there that she tried to do this the other day. She had values that violated her foreign key to primary key constraints already in her table. And then she tried to go back and define the constraint, and it said, oh, I've got this crazy error. I don't know what you're talking about. It was complaining because I can't do that for you because you've already broken the rules. So to prevent this from ever being possible, you would define your foreign key constraint. That's why we do it. To enforce referential integrity. That's the million-dollar word here. Referential integrity means if I have a foreign key reference, I can bank on the integrity of that reference having existence in the primary key table. Foreign key to primary key, you can trust. That's what it means. Cover those later. We got about 20 minutes before. Okay. Date time. Y'all are not really interested in the data types, are you? Let me go over the categories of data types, and I'll show you why you should pay attention to them. Whole number. Here are all the whole number data types, meaning like negative 1,000, 32,500. Whole numbers, here are the four. Big ints, enormous. You don't need it. Ints, that's your go-to. Small int, if you've got something that will never be bigger than 32,767 or smaller than negative that, then use a small int. Why? Because you're cutting your overhead in half and doubling your speed. Doubling your speed is usually a good reason. Tiny int. It only takes 1 byte to hold up to 255. If you have something that's only up to 255 or less, use a tiny int. Once again, it's 4 times better than an int. Done with ints. I'm not going to mention them again. Now, in the real world, you have the need to have significant digits to the right of the decimal, right? Money, yeah. Price, you need that stuff. There is a way you have to define these types of columns. So say we have a black market sale of penguins out the back door of my zoo. So I'm going to say black market transaction. And int, no primary key entity, and the penguin ID. I don't actually have penguins in the table, so we'll pretend. And the price. This is why I'm doing this. So the price of my penguin that I'm selling at the back door, by the way, I would never do this. I'm not that kind of guy. But you could say numeric. And the price, money, you usually only care about 2 digits to the right of the decimal. But I might charge $10,000 for a penguin. Okay? So if you want to have the maximum price that I'm ever going to reasonably charge for a penguin be $100,000. And I probably don't care about the decimals, but that's the maximum price I would ever care about charging for a penguin. So how do you say that? Numerics, decimal is also another type that you can use for this. You specify how many total digits do I want you to remember, database. So in this one, count both to the left and the right. 1, 2, 3, 4, 5, 6, 7, 8. Precision. Scale is how many digits to the right of the decimal? 2. Okay? So precision and scale. Whenever you define a number that has significant digits, it's normally the practice. You want to say, how many digits to the right of the decimal do I care about? And then you say, how many total digits? You would think that this would be like 6 to, like 6 to the left, 2 to the right. That's not how they do it. The comma isn't really part of it. It's a little bit confusing there. And the decimal is kind of, by saying you only want 2 to the right, it infers the decimal. So it's only the digits that matter like that. I just wrote that to be human readable. So good point, though. So Bethany said that I thought it would be 10. And it's like, well, you're right because I wrote 10 characters on the screen there. But the comma is really just for humans. And the dot, the computer can figure out because you're saying I only want 2 to the right. So if I made that 10-2, how much bigger a number could I have? What's the maximum price I could charge for a penguin with a 10-2? $99,999.99. Okay? If I change this to be $3,100, what does that mean? What? Not $100. I could, because there are 3 total digits, I've got 2 to the left and I got 1 to the right. $99.09. Yeah, $99.90. It doesn't really make sense with money. 1 means only 1 significant digit, so I couldn't even charge to the pennies. But if I'm charging $10 million for a penguin, I probably don't care about the pennies anyway. So,
why is that 99 and not 99?
Because there are only 2 digits maximum I have on the left-hand side. So 3 here means 3 total digits.
Okay.
And so I'm 1, 2, 3, and then one of those digits is on the right. So the point is, this is how you specify floating point, your decimal numbers. Now, if you don't want to think about this, the wrong way to do it, there are 2 other data types called real and float. Real and float say, approximate numerics. So it's going to say, I'll try to figure it out for you. I don't like the computer trying to figure out things for me because it's going to chop things off where I don't want them to. And if I charge $100 million for a penguin, I want to make sure I get paid. So I'm going to drop the penguin selling thing, but you get what I'm saying. So numerics and decimal, this is often the real world how you see that. You're saying 18 total digits, that's the maximum size of number, and 4 of those digits, 4 of those 18, are on the right. So I can have down to the thousandths position kept in track. Now, if you try to add more significant digits, what happens? It rounds it. If you try to add a bigger number than you can handle on the left, Probably an error. It's like I can't handle that big a number. Okay, so that's numerics. Strings. You thought you knew about strings. So I'm going to save, let's make this so much better. I'm going to sell lions instead of penguins.
You're going to have to start calling him Mr. Popper.
Yep, Mr. Popper. Okay, so lion ID, and now I'm going to say, what's the lion's name? Because lions deserve names, unlike penguins. Leo. So I'm going to say sometimes lions have 4 or 5 different names, unlike humans. So I'm going to make that big. And unlike humans, they don't have multiple fields. They like to have just one name, like Prince. So varchar. How many characters on disk is varchar going to take up? Up to 100. Up to 100. Var means variable. If you want to say always 100 characters, char. Char means its fixed length 100. There are 2 others. If you go to Germany, they have some crazy characters called umlauts and the little dots, and if you go to Mexico or Spain, they have accents and they have enye's, and they have some other things going on. Those may or may not be part of the normal ASCII character set. If you go to Japan, they certainly don't use the ASCII character set. How do you make it so that your database can be used by people who use non-standard characters? Unicode. So the Unicode character set says, I want to be able to accept not just the normal ASCII character set. I want to say whatever text they can dream up, I'm going to let it be in there. So this is fixed length Unicode, and there's a variable length Unicode. If you don't need Unicode, why wouldn't we just always do Unicode? It's like just in case somebody from Japan wants to use this application I wrote. Brianna has it exactly right, because you have a performance penalty of double if you use Unicode. So 100 characters, internally, there are 2 bytes for every character represented in Unicode. So when I say in varchar, it's actually 200 bytes. Varchar is 100. So if you don't need the special character accommodation, don't do it, because you're sacrificing performance with no reason. If there is even a remote possibility that somebody from Japan is going to put some text in there that is valid, that you don't want to give them an error for, do it. It's only overhead, and that's why we build databases, so you can actually run applications. But if there's no chance, don't by default, without thinking about it, just do n. N varchar means Unicode, or n char. In the real world, I very rarely use fixed length. Char and n char, do I really know that something's always going to be 10 characters or 50 characters? It's not often. Most of the time, it varies. So those are the 4 string data types. I've taught you about numbers, strings. How do you say true, false? So is sold. Bit. True or false? How many bytes on disk does that take? Just 1. 1 is the smallest you can have. Yeah. Byte. Yeah, byte. But a byte is the smallest increment on disk that you can store. But bit is a piece of a byte. 8 bits in a byte. So it's not even a byte, but you have to store at least 1.
Can you comment?
Can I comment? Yeah, comments in SQL is like that. This is 1 byte disk. This is always 100. Actually, not. This is 200 because it's n char. So if I were going to join on name, you've got 200 characters versus an int, which is 4. And by looking at it, it's not self-apparent. Why is it so slow? If you've got 1 million lions being sold out the back door, you're going to notice a difference. That van's going to have to hold up and wait a minute while I process the transaction. So, any questions about data types or why it matters? Data types matter because of speed. Now, if you want to throw at an entire PNG, or if you've got your entire video from YouTube about how to explain how to use databases, and you want to put it in a database, can you do that? Yes, you can. There are text and image data types that you can store up to, I think, 2 gigabytes of data in one field value. So stash it all in there if you want. You might want to consider storing it somewhere else and having a URL reference it, just so you don't bloat your database, but you can do it. So date, small date time, date time 2, int, small int, tiny int. These are whole numbers. This is true or false. These are numbers that have significant digits to the right of the decimal. These are strings. And this is enormous pieces of information. Okay, when we come back, we're going to write real-world SQL select statements. I really intended to skip over this bit and even more if you're interested. Here is a whole bunch of stuff that are really, really fun things to do that I'm not going to have a chance to teach you because we don't have time enough today at least. We can come back to this, take a look at this online, see if you're interested, have a special request. We are going to go over SQL selects. So between now and lunchtime and over lunchtime, I want to make sure that you've restored successfully the Sequila database to your local SQL Server instance. I don't care about MySQL or PostgreSQL right now. Just the first bit, make sure you have your SQL Server version of the Sequila database restored. You've got tables, and just right-click and say, give me a few rows from film or what have you, and you should have that in there too. Because when we come back from lunch, we're going to actually start writing real-world select statements against this. So, do you all have the questions that I posted? Like, what are the 10 questions? No? I'll drop it again. So you'll see the 10 questions pop into announcements in just a second. Go ahead and have lunch. Be thinking about SQL select statements because when we come back, I'm just going to give you, as a matter of fact, do you all want to go over some SQL select review or you just want to try your hand at answering these questions without it?
Review is good.
You want a little review? Okay. We'll come back and I'll do like a 20-minute review of SQL select anatomy, and then you're going to go off and try to do it yourself. So I'll post the questions in here momentarily. Have a good lunch.